The Kuiper Belt is a region beyond most of the planets in the solar system. It is located past the major planets, forming a vast zone outside Neptune, which is the 8th planet from the Sun. The first object observed in the Kuiper Belt was Pluto, discovered approximately 60 years before further objects were identified. On November 2, 2015, an especially clear image of the Kuiper Belt was captured by the James Webb Space Telescope, showing a donut-shaped area in the outer solar system. Named after the astronomer Gerard Kuiper, who contributed to our understanding of this region beyond Pluto, the belt was theorized in part by Kuiper in a 1951 scientific paper. Although his work primarily explored the possibility of objects existing beyond Pluto, he did not provide specifics about their arrangement. Clyde Tombaugh discovered Pluto in 1930 in what is now considered the Kuiper Belt. Initially, astronomers knew little about the outer solar system and assumed Pluto was a unique planet, despite its irregular orbit. The second Kuiper Belt object, KBO, wasn't discovered until 1992, over 6 decades after Pluto's discovery. This finding revealed that Pluto was part of a larger group of objects in the outer solar system. Since then, many more KBOs have been identified, confirming the presence of a region beyond Neptune that contains a variety of icy worlds. Pluto, once regarded as the 9th planet, lost its planetary status in 2006 when the International Astronomical Union, IAU, redefined what constitutes a planet. Now classified as a dwarf planet, Pluto played a crucial role in prompting exploration of the Kuiper Belt. The Kuiper Belt is an extension of our solar system, influenced by the Sun's gravity but composed of different celestial bodies than the inner planets. In contrast to the main asteroid belt between Mars and Jupiter, which is relatively sparse and rocky, the Kuiper Belt is a vast, icy region with about 20 to 100 times more mass. This makes it surprising that it took so long to identify it as a key part of the solar system. The Kuiper Belt is home to many notable dwarf planets, such as Haumea, Makemake, and Eris. Each has unique characteristics. Haumea, discovered in 2004, has a stretched, elongated shape possibly due to its rapid spin, while Makemake, identified in 2005, has a bright surface composed of methane, ethane, and tholins. Eris, also discovered in 2005, is smaller in diameter than Pluto but heavier, and its discovery played a role in re-evaluating Pluto's classification. This region of icy objects, which also includes comets, preserves early conditions and materials from the solar system's formation 4.6 billion years ago, offering a look back in time. The Kuiper Belt is distinct from the Oort cloud, which surrounds the solar system in a spherical shell and is thought to extend up to 200,000 Australian dollars from the Sun. The Kuiper Belt likely serves as the origin of short-period comets, while the Oort cloud is the source of long-period comets with elongated orbits. Both regions are rich in icy bodies and are crucial for understanding the broader structure of our solar system. The Sun can get a gleaming, extreme lethargy and a tail from the sun-based breeze. It's alright to be confused sometimes, but it's still vital to know the distinction. Researchers are stunned by this spot because the Kuiper Belt may only have a modest amount of material left over from what it looked like in the beginning. What we have now are, in a sense, just shards. The genuine material has already gone away, not by chance though. That's nice model is a set of ideas that says the orbits of the 4 largest planets in the solar system, Jupiter, Saturn, Uranus, and Neptune, could change in significant ways. It suggests that the big planets in the outer solar system haven't always been in the same circular orbits. Instead, they went through a period of dynamic orbital development. The model suggests that when these large planets interacted with one another, their paths changed greatly. It was once thought that the Kuiper Belt held 7 to 10 times the mass of Earth. However, the NICE model suggests that a lot of that material may have been lost as the orbits of the giant planets shifted. Material in the Kuiper Belt may have been spread out, ejected from the solar system, or moved to other regions due to the gravitational pull of the large planets and changes in their orbits. The Kuiper Belt is slowly being eroded because of what's happening. Collisions between objects in the belt can break them into smaller pieces, which can then collide with other objects in the belt. Other, smaller objects could turn into comets at various times. Those that don't become comets get squashed. The solar wind can carry the dust created when planets collide with one another out of the solar system. Scientists believe that the Kuiper Belt's matter doesn't weigh over 10% of Earth's mass. Altogether, it's not small, although that makes it seem small. It has been found that many objects in the Kuiper Belt have moons, smaller objects that move around a larger, primary object. This effect doesn't just happen on planets. It also occurs on other things in the Kuiper Belt. Some Kuiper Belt objects, KBOs, are also binary systems just like the moons. Two objects in a binary system orbit around a common center of mass, also known as their barycenter. The two objects are about the same size or mass. There are various types of orbital properties that these binary pairs can have. Some of these pairs touch, creating a shape that resembles a peanut. There is physical contact between the two parts in this arrangement, known as a contact binary. The gravitational forces pulling them together give them this unique shape. However, people didn't always know this. It took a lot of work from NASA. Pioneer 10 was one of the first to get close to it. Pioneer 10, launched by NASA on March 2, 1972, was a groundbreaking spacecraft designed to study Jupiter and the region around it. It was the first spacecraft to go through the asteroid belt. It was equipped with scientific instruments to study Jupiter's atmosphere, magnetic field, and radiation belts. Pioneer 10 was the first spacecraft to pass through the asteroid belt and get a close look at the gas giant. It made another important historical event when it became the first spacecraft to enter the Kuiper Belt in 1983. Although Pioneer 10 entered this region, it did not approach any icy worlds, as only Pluto had been recognized at the time of its launch. The primary mission of the spacecraft was to study Jupiter, and it sent valuable data about the gas giant back to Earth. Pioneer 10's path and longevity allowed it to travel far beyond the orbits of the known planets. It went just past the Kuiper Belt and helped us learn more about the farthest reaches of the solar system. This also motivated more missions to explore this distant and intriguing region. Later missions, like Voyager 2 and Cassini, helped us learn a great deal more about the outer solar system. Voyager 2's famous trip to Neptune's moon Triton in 1989 and Cassini's exploration of Saturn's moon Phoebe in 2004 both provided us with valuable information about these celestial bodies. Scientists think some of these moons came from the Kuiper Belt and were captured by the gravity of their parent planets. This did happen, even though most people don't know it's possible. In 2015, the New Horizons probe made history when it flew by Pluto for the first time. New Horizons took 4 photos of an object in the Kuiper Belt called 1994JR1 from 170 million miles away on its journey. This 90-meter-wide object gave scientists valuable data about the makeup and characteristics of Kuiper Belt objects. In 2014, the Hubble Space Telescope made a major discovery, 3 KBOs that were being considered as potential targets for NASA's New Horizons mission to Pluto. The telescope also found 2 small icy worlds in the Kuiper Belt at the edge of the solar system. This data, based on images taken on June 24 of that year, led NASA to approve a wider search for Kuiper Belt objects. The main goal of this intensive search was to find an object that NASA's New Horizons probe could closely examine after its flyby of Pluto. The 2 objects discovered during this search are about 4 billion miles away from Earth and are currently named 1110113Y and 072009F. Hubble has been observing the Kuiper Belt since 2003, when it took 2 images of an object in the belt called 2000FV53, 12 hours apart. This object was first discovered in Hawaii in March 2000 and was significant for guiding Hubble's observations. Hubble has since found 3 new Kuiper Belt objects. They are very faint, up to 100 times fainter than 2000 FV53, and can only be detected using computer analysis because they are too faint to be seen with the naked eye. One of these objects was tracked by Hubble's advanced camera for surveys on January 26, 2003. This confirmed that we were dealing with a very large object. Things became even more interesting when the James Webb Space Telescope joined the search. With its advanced capabilities, it offers new ways to observe and analyze things. The James Webb Space Telescope is a state-of-the-art space telescope that is excellent for studying the universe, including places like the Kuiper Belt. Because it uses infrared light. Infrared energy is emitted by everything warmer than absolute zero. The temperature of an object affects how strong this radiation is and where it goes. Since it is freezing in the Kuiper Belt, the infrared radiation from it has longer wavelengths. This makes it easier for the telescope to learn more about the Kuiper Belt. Different materials can have different infrared fingerprints. Scientists study the specific frequencies of infrared energy that an object in the Kuiper Belt emits or absorbs when they look at it with infrared light. From these spectral characteristics, the object's composition can be determined. Astronomers can determine what types of chemicals, ices, and rocks are on the surface of a Kuiper Belt object by examining its infrared spectrum. For instance, water ice, methane, ammonia, and other molecules have unique infrared fingerprints. Now, scientists can determine the composition of the object without relying solely on observations made with visible light. Infrared light is also better at penetrating dust and gas than visible light, providing a clearer view of space objects in places like the Kuiper Belt that may have dusty environments or thin atmospheres. This feature is especially helpful for studying the surfaces and characteristics of objects in the Kuiper Belt, as it reduces the impact of interference and obscuration from these materials. There are several thousands of these frigid things at the edge of the planetary group. They are actually the oldest bits of the nearby planetary system that still exist. Observations in the infrared range are perfect for concentrating on things that are cooler, like those beyond our solar system. Observations using visible light probably won't give us enough information about these cool things, but their infrared emissions do. These emissions show us insights regarding how hot they are. But that doesn't mean the JWST isn't also taking a gander at it. The James Webb Space Telescope's huge main mirror is an important part that makes it much better at making observations. The main function of a telescope's mirror is to gather and focus light from objects in space. In the case of the JWST, its 21-foot diameter mirror has a lot of surface area that can gather and focus light. The telescope can now pick up fainter signals from distant objects because of its increased light-gathering power. This makes it especially useful for studying the Kuiper Belt, where many objects may be faint or far away. It's also hard to see because the region is constantly emitting sun dust. Protective eyewear is recommended. The telescope can also create clear and sharp images because of the size of the mirror. The JWST can see more fine details in the structures and surfaces of Kuiper Belt objects since it has a larger mirror that allows it to do so. This is important for getting precise and clear data about these faraway objects. Because of how significant this finding is, you need all the accurate data you can get. Having something like this on board is extremely helpful. The JWST's large mirror makes it ideal for examining targets that are so far away. This allows researchers to learn more about the composition, properties, and movement of Kuiper Belt objects. On top of that, the telescope has a sun shield that keeps the sun's heat and light off its sensitive sensors. This sun shield is very important for keeping the telescope's operating temperature low, which is needed for good infrared views, and it also blocks the sun's radiation. After hearing all of this, you might think it sounds like a huge telescope, but that's not the case. These were made to be the most powerful ones we'd ever used. It has an advanced set of scientific instruments, each built to make specific observations and analyses. These cutting-edge additions make it easier to study things in space with the telescope, regardless of how far they are from Earth. One of the main tools on board is NRCam, which is designed to take high-resolution images in the near-infrared range. Astronomers can see the faintest objects overhead, even those in the Kuiper Belt, because it has a wide range of wavelengths. Since it can capture infrared light, NRCam is perfect for studying the thermal emissions and surface features of distant objects. Along with that is NRSpec, a spectrograph that works best within the near-infrared range. Astronomers can study the light from space objects by breaking it down into its individual wavelengths. This feature is very important for understanding the makeup, temperature, and environmental conditions of objects in the Kuiper Belt. Spectroscopy gives us a lot of information about the chemicals that make up these distant objects. MIRI, the mid-infrared instrument, works independently and can capture both images and spectra. MIRI's ability to capture mid-infrared radiation adds to what the other instruments have observed, giving us a complete picture of items in the Kuiper Belt. Additionally, there's the slitless spectrograph and the near-infrared imager, which have many functions, such as precisely guiding the camera, imaging, and spectroscopy in the near-infrared range. The fine guidance sensor helps keep the telescope pointed accurately, which ensures that the views are correct. FGS makes it easier for JWST to take clear pictures and measurements in the near-infrared range. These tools work together to make the James Webb Space Telescope able to capture the sharpest images of places like the Kuiper Belt. These photos give us more information about things we had previously only seen in vague, blurry images. One of the most famous objects we've ever found in the Kuiper Belt is Arrokoth, a word that means sky in the Powhatan Algonquian language. Its length is about 22 miles, and its width is around 12 miles. It has an interesting look, thanks in part to its elongated shape. The shape of Arrokoth is a contact binary with two lobes that are 13 miles long and 9 miles wide along their primary directions. These lobes meet, creating a unique double shape. The orbit of Arrokoth around the Sun has a period of about 298 years. Even though it seems a bit irregular compared to other round objects in space, its orbital inclination and eccentricity are both very low, which means that its path is stable and easy to predict. This is one of the oldest objects ever discovered in the Kuiper Belt. The James Webb Telescope has already given us a lot of information about objects that other projects have found, so it's only a matter of time before we learn even more. Can you think of something else that might be out there? Write your response in the box below. Feel free to give this video a thumbs up if you like it, and we'll see you in the next video.